Have you ever seen pictures like these? They're made using a technique called high-speed photography, which is all about catching fast action at just the right moment. With a DSLR, an Arduino, a flash, and a few other components, we're going to build our own basic high-speed photography rig. And what does the wine glass and hammer have to do with anything? Well, stick around and find out. Here's what we'll need. First, an SLR, or a camera that has a full manual mode. An external flash, an Arduino, any kind will do, but I'm going to use the Nano for this project. An opto-isolator chip. As a sensor, we're going to use this piezo element from Radio Shack. And you may also want to get some flash interconnects and cables, but you may be able to get by without them depending on what type of flash you have. And of course, you'll need a breadboard, hookup wire, and resistors. First, let's talk about opto-isolators. We can learn a lot about them by looking at the schematic diagram. On one side, we have an LED, on the other, a phototransistor. Without voltage on this side, the switch is open on this side. When we apply voltage, the LED illuminates, which causes the phototransistor to close the circuit on this side. There are no electrical contacts shared between each side of this component, which makes it great for isolating parts of our projects. In this case, we want to isolate the flash's voltage from the Arduino. So now let's use the opto-isolator to trigger the flash. There are many different types of flash connectors, but most flashes have these hot shoe connectors on the bottom and will fire when you close the connection between the contact on the bottom and inside the flange. Now you can either jury-rig your own wires to these terminals, or you can use a PC sync cable. Some flashes like this one have a built-in PC sync port, which looks like this. But you can make any hot shoe flash PC sync capable if you use a hot shoe adapter. Hot shoe adapters and PC sync cables are very cheap and are available at many pro photo shops, or you can check out flashzebra.com for a nice selection. I'm going to plug my PC sync cable directly into this flash, and as you can see, when I connect the leads, the flash fires. To connect these leads to your opto-isolator, put it into the breadboard like this, with a dot on the upper left. Just like the schematic diagram, the switch we're closing is between the two pins on the right. Now use a current limiting resistor to connect the digital out pin of your Arduino to the first pin of the opto-isolator on the left. The pin below that to ground. Now when you bring this pin high for a moment, it will close the connection between the two pins and the flash fires. Now let's talk about our sensor. I want to get a photo of a balloon mid-pop, so I'm going to use the piezo sensor with a red lead connected to an analog in pin and the black to ground. Connect a 1 mega ohm resistor parallel to that, so it'll be the same pin and ground. This will keep the reading steady to ensure that only a loud pop will trigger the Arduino. I'm also going to hook up a button so that we're ignoring any input from the sensor until we're ready. Let's take a quick look at our code. When we first start the Arduino, it'll be in standby mode. In this mode, it'll ignore input from the sensor and won't trigger the flash. After we push the button, it starts to listen for the pop. As soon as it hears the pop, it triggers the flash and then goes back into standby mode. The camera shutter is going to have to be opened before the flash fires because the shutter is not fast enough to open to catch the action. Therefore, we have to work in a dark room and have the shutter already open when the balloon pops, either by setting a long exposure time or using our camera's bulb mode. Let's put the whole rig together now. I have my camera set up on a tripod and I've set the aperture to the camera to make the appropriate exposure based on our flash output. You'll want to set the flash output as low as possible. This is because with a flash such as this one, the flash output is mainly controlled by the duration of the flash. The lower the flash output, the less time the bulb is illuminated. Since the pop of a balloon is very fast, we need a quick burst of light in order to reduce motion blur. So you don't need to use an Arduino for such a simple circuit, but I wanted to extend the project by using a power tail relay to shut off the lights when I put the device into active mode. And I wired up my camera's remote shutter jack to another opto-isolator so that after the lights go out, the camera automatically opens its shutter. Okay, I've got everything rigged up and I'm ready to go. Let's see if this works. I'm going to push the button, it'll turn the lights off, then open the camera shutter. After the camera shutter's open, it'll listen for the pop. When it hears the pop, it'll fire the flash and then close the camera shutter. And then turn the lights back on. Let's see if it works. Here we go. Let's see how that looks. Not bad. So now, as promised, I have the wine glass and the hammer. Let's see how this looks. Worked pretty well. There's so much you can do with high-speed photography and all the different types of sensors. If you're looking to build a more advanced version, check out cameraaxe.com for lots of great resources. And while you're here, I want to hear your feedback. Leave a comment, give a thumbs up, and thank you for subscribing. I have a great new video coming out in a couple weeks, and you're not going to want to miss it. So long.